So today we are going to talk about our remaining topics related to enzyme.
Yes, sir.
So the one important thing is you have to understand here, that is the measurement of the rate of an enzyme controlled reaction.
Yes, sir.
In this concept, we will try to understand that what is an instrument which is commonly used to measure the rate of enzyme.
Mm,
So use of calorimeter.
yes, sir.
This is a technique and instrument calorimeter which is commonly used to measure the rate of an enzyme.
Yes, sir.
Rate of an enzyme. And definitely this rate of enzyme can only be measured in a controlled reaction where reaction is controlled, where reaction is under your control. Anybody who is performing that reaction in a laboratory, so that is a controlled reaction.
Yes, sir.
Our objective here is to understand that how this calorimeter is used to measure the rate of enzyme. Here the most important thing is color change.
Yes, sir.
Color change. You should keep in mind this concept, how it is.
Yes.
Calorimeter measure the light of transmission, or you can say absorbance, passes through a substance and give quantities reading. You just consider it in a way that you have a screen here, right?
Yes, sir.
And there will be we call it cuvette. There is a very small container like this. You have to add your reaction here.
Ye-
Whatever you are reacting solution, you have to place in it, in this cup, in this small container which is called cuvette. That's not your concern, but it is. But you should consider in mind that I am just trying to elaborate this concept, that how the color change in calorimeter actually helps to understand the rate of reaction. Whatever we are going to do is actually we are doing here, we are trying to understand, or we are trying to observe the absorbance. Absorbance. How? Here's a screen. There is an instrument that is a calorimeter here. You have to place this cup in this calorimeter.
Yes, sir.
Then you have to bombard a light on it, right? Light source. There will be a light source which is connected with this meter, with this instrument, right? There are different colors which would be present in this light, and they will strike on this cup,
Yes.
right, and pass through it. there will be some colors, which will be absorbed here in this solution which is present in this cup,
Okay, sir.
right? And when they will absorb, definitely they will not pass, they will not cross this cup to move to the other side of the uh, screen. So whatever is absorbed here, that absorption rate will be shown on this screen. There will be some reading like 0.8 nanometer, like 0.7 nanometer, like this.
Yes, sir.
What there would be a reading here. What this reading is going to show you? This reading is actually showing you absorbance. What do you mean by this absorbance? This absorbance means the amount of light, which the amount and color of light which is absorbed by this reacting solution which is present in this cup,
Yes, sir.
right? And that absorbance is actually shown on the screen, and from there we will get an idea and the data that what is the rate of chemical reaction. Remember, when the rate of reaction is greater,
Yes, sir.
right, there will be a greater absorption of that light. At the initial stage, the light source that you have provided, the color of that light and the amount of that light which will be absorbed, that will be less, right? With the passage of time, as the rate of reaction is getting increased,
Yes,
we can detect that rate of reaction by absorbing, yeah, by analyzing the absorption of that light. Definitely, when the rate of reaction is increased, so light absorbance is also increased,
yes,
right? Are you getting this point?
yes, sir.
So that's a very simple concept. For instance, you have an example here. You have amylase.
Yes, sir.
What is its function, amylase? What is its function, man? What do you think? What it will do? This amylase, what it's going to do here? Its function is to
Digest
break this
carbohydrate.
starch,
Yes, sir.
to, for instance, to maltose,
Yes, sir.
right?
Yes, sir.
So calibration of calorimeter by passing light through light iodine solution show 100% transmission. What you will do here, the calorimeter that you are going to use,
Yes.
first you have to check its performance.
Okay, sir.
Is it 100% absorption or not? So for that purpose, you will use a standard solution that is of iodine. This iodine is just a solution which is used to check its performance, to check its working, whether it is good or bad. If
Yes.
it is, if the absorption of this iodine is 100%, then we will say this calorimeter is 100% perfect. Now you can use it for test, right?
Yes, sir.
Okay, so after calibration, this is what we call calibration. I mean, whatever the instrument that you are going to use in laboratory,
Yes, sir.
so first you have to calibrate it.
Yes,
For
sir.
an might be you have used microscope. Before using that microscope, you have to calibrate that microscope. You
Yes.
have to standardize that microscope, whether its function is correct or not, so that your reading could be uh, I mean, correct after your check. All right. So this was the brief concept about how to use calorimeter, why it is used. Calorimeter is an instrument that has actually the you can say that has the ability to absorb some amount of light, right? So it has the property to reflect light, not to yes, disperse or reflect light, and other is absorb light,
Yes, sir.
absorption. And the light which is not absorbed, that will be dispersed and passed through that calorimeter instrument. So we have to check this absorption, the absorbed light.
Yes.
This absorbed light will actually show us the rate of reaction, right?
Yes,
So our function was to find out the rate of reaction. The rate of reaction of any chemical reaction. What we are going to check here? We are going to check here the function of this enzyme. If the rate of reaction is greater, what does it mean? Or is?
कि सर जी एंजाइम जो है वो
Yes, that enzyme is functioning greater. That enzyme is performing its function at a larger rate, right? So rate of reaction is directly linked to the rate of involvement of the enzyme.
यस सर
The more, if your enzyme is more active, it means the rate of reaction is greater, right?
यस
So
सर
this is how you are actually measuring the rate of an enzyme in a chemical reaction, in a controlled chemical reaction. And anybody asks you how you can do this, we can just check the absorbance of light,
यस सर
right? We have a source of light here. For
यस
instance, you have a source of light and you are bombarding this source of light somewhere. There would be a 7 colors in it. Indigo, you know very well. I mean, commonly red, green, yellow, and all these indigo. There are about 7. So and few of the colors will be absorbed by this enzyme, right?
यस
So
सर
we will check the wavelength of that light which is absorbed by this cup, this cuvette, which has the reacting solution in it. So from there we will observe the reading which will come on the screen that will show us that what is the rate of reaction right now, right?
यस सर
This was the concept about the activity of how we can measure the rate of enzyme action.
यस सर
Then you have another concept, that is enzyme affinity.
ओके सर
Enzyme affinity. Okay. Enzyme.
affinity
What do you mean by this affinity?
the willingness of enzyme to bind with the substrate.
Yeah, affinity means attraction. Affinity mean uh, what we would say about, like, uh, how we can understand this concept, that what do you mean by this? Affinity means to have some affection, to have some relation, attraction. More commonly we can say attraction. So enzyme affinity.
Yes sir.
You have, I think, you have studied this concept in chemistry as well. Electron affinity,
Yes sir.
in the concept of electron affinity. So that's affinity here we are using. So what enzyme affinity, what does it mean?
The willingness of an enzyme to bind with the substrate, sir.
Yes, here we can say variation in speed
Okay sir.
in which enzymes work, at different speed.
Yes sir.
Different speed. In other words, rate,
Yes
at
sir.
different rate, right?
Yes sir.
So there we will use here another concept, that is V max. V max means velocity maximum. Here we can say maximum. What do you mean by this V max? It means maximum active site of enzymes occupied by substrate. This is what we call Vmax, V maximum, velocity maximum,
Yes.
right? So now you have to use a concept here, that is flow. ये हमारे MIT Michaelis Menten constant. Michaelis Menten constant. We are using it, this concept. This is, we can mention it here like Km.
Yes, sir.
It is a constant, remember.
Yes, sir.
Km, there is a specific value of this Km, whatever we are using for in equation, we can use it. So there we can find out it. So more affinity of enzymes with substrate, so initial rate is higher,
Yes, sir.
right? The higher the affinity, the lower the Km rate. Now
Okay.
you should keep in mind one. The Km, what is Km? Km is a Michaelis Menten constant. It is a constant. So if the affinity of the enzyme is higher, so Km value will be lower,
Okay, sir.
right? If it will be low, it has indirect relation with enzyme affinity.
Okay,
In
sir.
other words, right?
Yes,
So
sir.
higher the affinity, you can mention it by arrow like this. So here you can mention this arrow in a downward side. It shows lower the Km value. What is Km value? Km value is a Michaelis Menten constant. These are the scientists who actually first time studied them in an enzyme affinity. So that's why we call it Michaelis Menten constant. We
Okay.
will use it to understand this more while drawing some graph. So there you can understand it, right?
Yes, sir.
So for instance, if the enzyme activity of enzyme affinity of the less affinity of the enzyme with substrate, what would be the condition? There is a condition that enzyme affinity is lower or less. What would be the condition? It means initial rate of that reaction will be low.
Yes, sir.
Definitely, if the enzyme activity, if enzyme affinity is lower,
Yes, sir.
what does it mean? It means that the substrate enzyme interaction will be less.
Yes, sir.
And it means that the rate of reaction is less. The
Okay.
rate of reaction is low, right? So this is a relation that we are trying to understand here, that how Km value impacts the rate of chemical reaction or the rate of enzyme action,
Yes, sir.
right?
Yes, sir.
Okay. Now, Km value, what is this Km? Km, I have told you that this is a Michaelis Menten constant. You should
Yes, sir.
keep in mind. So Km value, when this Km value will be same or when this Km value will not affect. So it would be same when for enzyme without inhibitor.
Okay, sir.
Without inhibitor. And definitely, if that is without inhibitor or non-competitive, we will use this term as well here because we have to study this as well. non-competitive and competitive inhibitors. Last time we have started this topic, but these are two basic concepts. We need to complete them and then we'll go on the inhibitors as well. So non-competitive, we will understand that I have told you in our last class that what do you mean by this non-competitive? It means they are not fighting or they are not competing for the active site.
Yes, sir.
Non-competitive, right?
Yes, sir.
So in that condition, this Km value will be same. That is not going to change.
Okay.
So those enzymes which are competing for any competitive inhibitor,
Yes, sir.
if they are competing for any competitive inhibitor, then Km value will be
And decreased.
no, Km value will be different. That Km value will be like they have the same Km value that V max had,
Yes, sir.
that we have shown above, right?
Yes, sir.
So compared to the enzyme without inhibitor, which reaches the Vmax by increasing substrate concentration. So this is the condition where you have the competitive inhibitor.
Yes,
But
sir.
if you don't have any inhibitor there, then this Vmax will be achieved by how? This Vmax will be achieved by increasing substrate.
Yes, sir.
You have to increase the substrate concentration if you want to get this Vmax,
Yes.
right? In what case? In that case where you don't have any inhibitor. But if you have any inhibitor, there you don't need to increase the substrate concentration, right?
Yes, sir.
So in, enzyme with competitive inhibitor has different Km value but have same Vmax as compared to the enzyme without inhibitor. So we have compared this Km value in competitive and non-competitive inhibitors as well. So what do you mean by this all? Why we have studied this concept here?
Sir, to
There we need to draw. There we need to draw. We can say a graph here
yes, sir.
that can further elaborate this concept. That what it is. For instance, here is Vmax, maximum V value, like that you have. Then you have here you can mention the rate of reaction, right?
Yes, sir.
So you can mention it 20, 60, 80, 90, 100, whatever it is. So like here I'm showing 20, here you can show 60, so here is one like 80
Yes,
or
sir.
80 like here, you can mention it here, right? So here it may be 70. So at this point, you may have conditions.
Okay,
There
sir.
would be a condition where you have here you can show substrate concentration. A graph where you have without an inhibitor. Without inhibitor. We have mentioned before as well. Without inhibitor, there will be Vmax,
Yes, sir.
maximum velocity that you will get by this enzyme. When you are reacting a chemical reaction in which you have enzyme, but that enzyme does not have that chemical reaction does not have any inhibitor, right? So at that time, the rate of reaction will be maximum. The speed of the reaction will be maximum in
Yes,
the
sir.
presence of that enzyme. right? But for instance, you have a competitive inhibitor. So definitely when you have competitive inhibitor, then there will not be a maximum V.
Yes, sir.
Then it is possible that you may have half V max
Okay, sir.
at this point. At this point, here you can show competitive. Why it is so? It is very easy, or is you can easily understand if you have a competitive inhibitor. For instance, you can imagine anything like any person who, when you are running, any person who have a same weight like you, same height like you, and if you are running and he or she are they any of them, if they are stopping you, if they are restricting you or limiting you, so definitely your speed will be lower. Are you getting this point? For instance, anybody trying to put obstacles in front of you, try to capture you, or to do anything to lower your speed. But for instance, if you have no any hindrance in your surrounding and you are allowed to run,
Yes, sir.
so in that condition, your speed will be maximum. So in this condition, there is a competitive inhibitor. So if competitive inhibitors are there, so speed of that reaction will not be maximum as it was in case of without inhibitor. Are you
Yes.
getting this point or not?
Yes, sir.
So there is another condition. There you have inhibitor, but those inhibitors are non-competitive inhibitors.
Okay, sir.
What does it mean? Although you are increasing the substrate concentration in this site,
Yes, sir.
but what's going on here? The rate of reaction is further declined.
Okay, sir.
Why? Because now you have the non-competitive inhibitors. Now
Oh,
it is important to understand how these non-competitive inhibitors lower the rate of reaction,
yes, sir.
how they will affect that enzyme. I have told you in our last lecture, for instance, you have a globular structure of enzyme like this, and you have the active site. You can mention any active site like like this. I'm again drawing this like this. You have a condition. So if inhibitor is competing for this site, that is a competitive inhibitor. But
Yes.
if that inhibitor is binding here, if that inhibitor is binding here, remember, by binding the here on the globular part of this enzyme, it will also affect its shape.
Okay.
Its shape will be changed. Once the shape of the enzyme will change, this active site will not be able to bind a substrate, a specific substrate,
Okay, sir.
right? So
Yes.
if you have the more non-competitive inhibitors in a chemical reaction, as a result, the rate of reaction will further decline.
Yes, sir.
All right. So what we have learned here, we have learned that if you have an inhibitor there, what we are trying to understand, we were actually trying to understand the rate of reaction, a rate of enzyme action in we were trying to understand the enzyme affinity. So if you have the inhibitors there, if you don't have any inhibitor, it means you have the maximum enzyme affinity with with a reaction,
Okay, sir.
right? But if you have some competitive inhibitors, then it means substrate will fight for the site of active site. So the rate of reaction will be lower.
Yes,
In
sir.
other words, if you have the non-competitive inhibitors, the rate of reaction will further, there will be a more competition there, and rate of reaction will further decline.
Yes, sir.
So this is how we have to understand. So now the last concept of this topic is that is we left in our last lecture. That is what? That is the inhibitors types. So which one you have already studied?
The competitive and non-competitive.
Yes, competitive and non-competitive. So let's conclude us by having some more concepts here. Okay. A reversible inhibitor,
Yes, sir.
and then you have irreversible inhibitor. Irreversible inhibitor.
Yes, sir.
This reversible inhibitor can also be divided into like we can say competitive reversible inhibitor. I can add here competitive reversible inhibitor.
Yes, sir.
So this irreversible inhibitor, which is here, and you can also divide it non-competitive reversible in. So here you have a reversible inhibitor. You can add here non-competitive
सर
non-competitive.
ये नॉन
जी जी.
कम्पेटिटिव रिवर्सिबल इनहिबिटर क्या है?
Non-competitive reversible inhibitor or competitive reversible inhibitor. Let me show you. Listen, race.
Yes, sir.
Here you have a enzyme,
Yes, sir.
right? Competitive reversible inhibitor will be a inhibitor once it is once. Listen, it's important to understand carefully. Once a substrate will bind on this active site, or inhibitor will bind on this active site,
Yes, sir.
right? So if you will increase the substrate concentration,
Yes, sir.
right,
Yes, sir.
you can do what? You can break this bond.
Yes,
This
sir.
inhibitor active site complex, ES complex.
Yes,
You
sir.
will break this ES complex
Yes,
by
sir.
increasing the rate of substrate, right?
Mm.
This is the one way. So what we call this? We call this
Competitive.
competitive reversible inhibitor,
Yes, sir.
right? And you have another condition. Here again, you have an enzyme and you have the non-competitive reversible inhibitor. It means the inhibitor will has the inhibitor which is there that has not any competition on the active site.
Yes,
That
sir.
inhibitor will actually bind on the
Allosteric site.
other part of the enzyme.
Yes,
Like
sir.
here, it can bind here.
Yes.
Now there is another condition, like you can remove this inhibitor,
How?
right? You can remove this non-competitive reversible inhibitor if the molecule binds to another part of the enzyme rather than active sites. It disrupts 3D shape of the enzyme and hydrogen bonding. Due to this enzyme, active sites may change, so substrate may not fit. Sometime positive role in enzyme controlled reaction. so I have so I have told you.
सर ये
So
रिवर्सिबल कैसे है?
reversible ऐसे है बेटा, you can remove this inhibitor from here
कैसे?
by any method. Like for instance, you are increasing the substrate concentration here because 3D structure was changed because of this inhibitor.
सर
But
जी
if you have
सबस्ट्रेट
increased,
अगर
जी बेटा,
इनहिबिटर बाइंड हो चुका है, 3D शेप चेंज हो चुकी है, तो सबस्ट्रेट
हाँ
बाइंड तो
जी,
हो ही नहीं पाएगा.
but that is for temporary, because if you will increase the substrate concentration there, and if you will somehow, because it is a reversible, no, it is possible that this inhibitor may also detach from this globular part of the enzyme by itself. This is the one way. Definitely, if you have a small number of substrate, they will not change the shape of the this active site, because this active site shape is temporarily changed, because it is reversible. This inhibitor can be removed from here because there are just hydrogen bonding, and those hydrogen bonding can easily broken down by increasing the concentration of enzyme or by increasing the concentration of substrate. So our point is
सर
that
जी
you can remove.
यही तो पूछ रहा था कि अगर हाइड्रोजन बॉन्डिंग चेंज हो जाएगी ये इनहिबिटर के आने से,
जी जी।
तो शेप चेंज हो जाएगी एक्टिव साइट की,
हम्म।
तो ऐसा क्या होगा कि वो एक्टिव साइट के ऊपर सबस्ट्रेट बाइंड हो जाएगा दोबारा? शेप तो चेंज ऑलरेडी हो चुकी है।
I have told you that it is a temporary non-competitive inhibitor. There are many other ways to remove these inhibitors. Normally, we use some chemical, we use some drugs even to
सर
remove
उसे
these inhibitors.
उससे जो हाइड्रोजन बॉन्डिंग है वो दोबारा
जी।
हो जाती है, उससे
That
दोबारा?
can be broken down.
नहीं, वो ब्रेक डाउन होगी, लेकिन वो अगर ये रिवर्सिबल है तो हाइड्रोजन बॉन्डिंग दोबारा हो सकती है फिर?
If the substrate is binded here, it is possible that it may not attach. It is a competition. It depends. If there is no substrate bind on this active site, so this shape can easily be changed by this inhibitor,
यस सर।
right?
यस सर।
So once the substrates are attached on this active site in any
यस सर।
enzyme, so this inhibitor will not be able to change too much this shape. But if the shape is changed somehow,
यस
it
सर।
is reversible. Reversible means reversible means that this enzyme may gain its function by removing this inhibitor from here.
ओके सर।
Right? Now you will understand this concept here. Non-competitive but irreversible inhibitor.
ओके सर।
What do you mean by this? It means that, for instance, certain chemicals like metallic ions, right? When they will attach, or they cause protein to precipitate, for instance, you have some this chemical, right? You have some this chemical. Once they will bind with enzyme, its globular structure, not on the active site,
यस सर।
right? Because these are non-competitive, but it is irreversible. Once they are attached on this side, they will not going to remove from here.
यस सर।
Whatever you do, they are not going to remove from here.
ओके सर।
So as a result, they will inhibit the function of this enzyme.
ओके सर।
Because they are inhibitors, they will inhibit the function, or they will inhibit the ES complex formation. This ES complex formation will not be possible here in this case, because the inhibitor is that inhibitor. This is a chemical, specific metallic chemical, which is attached on this. So it is not going to remove from here,
ओके सर।
right?